Imagine it is Friday at 5 p.m. You just hit the deploy button on a massive update that took months to build. Suddenly, the monitoring dashboard turns bright red. Users are seeing 500 errors, the database is screaming, and the only way to fix it is a stressful 40-minute rollback process. This used to be the industry standard, a high-stakes gamble where shipping code meant pushing it live to everyone at once. But today, the world's biggest companies, like Netflix and Amazon, don't live in fear of the deploy button. They use a powerful technique called feature flagging. Feature flagging allows developers to wrap new code in a conditional statement, effectively creating a remote-controlled switch. In this video, we are going to explore how these simple toggles have completely changed the way software is built and released in the modern era. Let's dive into the world of safe shipping.
At its core, a feature flag is just a conditional if statement in your code. Instead of hard coding a feature to be on, you wrap it in a logic gate that checks a remote configuration. Think of it like a light switch in your house, but instead of walking to the wall, you can flip it from a central control panel miles away. This simple abstraction solves the biggest problem in software, the all-or-nothing release. Before flags, if a new feature had a bug, you had to redeploy the entire application to remove it. With flags, you simply flip the switch back to off in a dashboard, and the buggy code is instantly bypassed for every user without a single line of code being changed or a single server being restarted. It turns a catastrophic failure into a minor 2-second adjustment.
One of the most powerful concepts feature flagging enables is the decoupling of deployment from release. To most people, these sound like the same thing, but they are fundamentally different. Deployment is the technical act of moving your code to a production server. Release is the business act of making that code visible to customers. In the old days, they happened simultaneously, which created immense pressure on engineering teams. By using flags, you can deploy code to production while the feature is still dark. This means the code is sitting on the server, but no user can see it yet. This allows developers to test the code in a real environment without any risk to the user experience. You can deploy on a Tuesday morning and release on a Thursday afternoon when marketing is ready.
Big companies love feature flags because they enable canary releases. Just like coal miners used canaries to detect toxic gas, developers release a feature to a tiny percentage of users first, say 1%. If the metrics look good and the error rates don't spike, they ramp it up to 5%, then 20%, and eventually 100%. If something goes wrong at the 1% mark, only a handful of people are affected, and the team can fix the issue before the general public ever sees it. This blast radius control is essential when you have millions of daily active users. It transforms a high-stakes launch into a gradual, data-driven rollout. You are no longer guessing if your code works. You are observing it work in real time with real traffic, while keeping the risk to your brand almost zero.
Beyond safety, feature flags are the engine behind modern A/B testing. Product managers use flags to show version A of a checkout button to half the users and version B to the other half. By measuring which version leads to more sales, companies make decisions based on hard data rather than the highest paid person's opinion. This experimental culture is why apps like Instagram or Spotify feel so optimized. They are constantly running hundreds of tiny experiments under the hood. Feature flags make this possible without needing separate builds of the app. You can even target flags based on user attributes, like showing a VIP feature only to subscribers or a beta feature only to internal employees. It's about delivering the right experience to the right person at the right time.
Let's talk about the kill switch. In a complex microservices architecture, one failing service can cause a cascading failure that brings down the whole site. If your new recommendation engine starts timing out and dragging down the homepage, you don't want to wait for a developer to fix the bug. You need to shut it off now. A feature flag acts as an emergency circuit breaker. By flipping the flag, you can disable the failing component and revert to a graceful degradation state. Maybe users don't see recommendations for 10 minutes, but they can still buy products. This resilience is what separates amateur setups from world-class engineering. It allows systems to be self-healing in the eyes of the user, maintaining uptime even when things are breaking behind the scenes.
Feature flagging also enables a continuous delivery mindset. Traditionally, developers worked on long-lived feature branches that were merged once a month. This led to merge hell, where integrating weeks of work from different people caused massive conflicts. With flags, developers can merge their code into the main codebase every single day, even if the feature isn't finished. They just keep the flag off. This is called trunk-based development. It keeps the codebase healthy and ensures that everyone is working on the most up-to-date version of the software. It reduces the overhead of managing complex branches and makes the team much faster. Big tech companies move fast not because they are reckless, but because their tooling, specifically feature flagging, makes moving fast safe.
However, with great power comes great responsibility. Feature flags introduce a new type of challenge, technical debt. If you never remove the flags after a feature is 100% rolled out, your code becomes a messy maze of if-else statements. This is often called flag debt. Top-tier engineering teams have automated processes to remind developers to clean up their flags. Some even have scripts that automatically create a ticket to remove a flag once it has been active for 30 days. Managing the life cycle of a flag, from creation to rollout to retirement, is just as important as the feature itself. Without discipline, the very tool that was supposed to make your system safer can make it too complex to understand.
So, how do you get started? You don't necessarily need to build your own flagging system. There are feature management platforms like LaunchDarkly, Split, or open source tools like Unleash that provide robust dashboards and SDKs for every major programming language. These platforms handle the complex parts, like ensuring flags are updated in milliseconds across thousands of servers, and providing detailed analytics on rollout performance. For many companies, the cost of these tools is a fraction of the cost of a single major outage. Whether you build or buy, the goal is the same: to move from a world of hope-driven deployment to data-driven releases. It is a fundamental shift in engineering culture that prioritizes safety, speed, and user experience above all else.
To wrap up, feature flagging is the secret weapon of modern software giants. It allows for decoupling deployment from release, performing canary rollouts to minimize risk, and running A/B tests to optimize products. It turns the terrifying release day into just another Tuesday. If you are a developer or a product manager looking to scale your impact, mastering feature flags is one of the best investments you can make. Thanks for watching. If you found this helpful, hit the like button and subscribe for more deep dives into the systems that power the modern web. Happy flagging, and may your deployments always be stress-free.